Hey everyone, and welcome. Artificial intelligence, or AI, it's a term that gets thrown around constantly. But let's be honest, it can feel a little abstract, maybe even a little sci-fi. So today we're going to pull back the curtain, demystify it, and really get to the bottom of what it means for all of us, right here, right now.
So, let's just start with the biggest question of them all. If you strip away all the hype, all the crazy movie plots, what is AI at its absolute core? What are we actually talking about when we say that word?
Okay, so here it is, the textbook definition. At its heart, AI is all about trying to get machines to simulate how we think. And the key words there are those three processes: learning from new information, reasoning to figure things out, and maybe the most amazing one, self-correction, learning from their own mistakes. It's not magic, it's a fascinating field of computer science.
So you might be wondering, why is AI exploding right now? Well, it's because it has become the engine for pretty much our entire digital world. Businesses are using it for everything, to finally make sense of these massive mountains of data they have, to automate tedious tasks, and to give us all those personalized experiences we've come to expect. It's the tool that turns raw data into smart decisions.
Now here's where things can get a little messy for a lot of people. A ton of the confusion around AI comes from mixing up what's real today with what we see in movies. So let's clear the air and break down the three distinct levels of AI. Getting this part right is, well, it's everything.
The best way to think about AI's potential is like a ladder with three main rungs. Down at the bottom, we have what's called narrow AI. Then we climb up to the more theoretical general AI, and way at the top is the purely hypothetical idea of artificial superintelligence.
And this slide right here lays out the most important distinction you need to know. On the left, you see narrow AI. And let me be clear, this is pretty much all the AI that exists in the world today. It's designed to do one very specific task incredibly well. Recognize your face, search the internet, recommend a song. It's a specialist. But on the right, that's general AI. That's the stuff from the movies. An AI that could think, reason, and learn any task a human can. It could go from playing chess to writing a novel to diagnosing a disease without skipping a beat. We are nowhere near that yet.
And then, at the very top of that ladder, you have artificial superintelligence, or ASI. This is the idea, the future theory, that one day an AI could exist that doesn't just match human intelligence, but blows past it in literally every field imaginable, from art and science to social skills. It's a wild concept, but for now, it's firmly in the realm of science fiction.
Okay, so now that we've established we're living in a world of narrow AI, where does it actually pop up? Well, the answer might surprise you. It's pretty much everywhere. In fact, I guarantee you've used it multiple times today without even thinking about it.
So the first thing to get straight is that AI isn't just one single technology. It's a whole family of amazing tools. A great way to picture it is like a big tree. AI is the trunk. And from that trunk grow all these different powerful branches. Let's take a look at a few of the most important ones.
First up, we've got the branch of vision. This is all about what it sounds like, teaching computers how to see and understand the visual world around us. This is the magic behind your phone unlocking when it sees your face. And it's how a self-driving car can tell the difference between a pedestrian and a stop sign.
Next, we have the speech branch. This is how machines learn to process and produce human language. It's the Siri or Alexa in your kitchen, understanding what you asked. It's your GPS giving you turn-by-turn directions. And it's those incredible real-time translation apps that feel like something out of Star Trek.
And that brings us to the absolute heart of it all, the real powerhouse of modern AI, machine learning. Honestly, if AI is the car, then machine learning is the engine that makes it go. This is the process that lets a machine learn from data and spot patterns all on its own, without a human having to write code for every single possibility. So the big question is, how in the world does this engine actually work?
All right, let's do it. Let's pull back the curtain and take a look inside that engine room. We're going to break down the three main ways that machines learn, and I think you'll find it's way more intuitive than it sounds.
So, machine learning really boils down to three main teaching strategies. You can think of them as different training styles for a computer, and each one is perfect for a different kind of problem. They are supervised, unsupervised, and reinforcement learning.
Let's start with a really simple question. How would you teach a small child to recognize an apple? You'd probably show them a bunch of different apples, and each time you'd say the word apple. You're giving them examples with labels. That's the whole idea behind our first method. And that is exactly what we call supervised learning.
You feed the machine a gigantic dataset where humans have already labeled all the answers. This picture is a cat. This one is a dog. This email is spam. This one is not spam. After seeing millions of these labeled examples, the model starts to learn the underlying patterns so it can make predictions on brand new data it's never seen before.
Okay, but what if you don't have all the answers labeled for you? What if you just have a giant, chaotic mess of information? Well, imagine I dumped a huge bin of mixed-up Lego bricks on the floor in front of you. What would you do? You'd probably start sorting them on your own, right? Grouping them by color, by shape. You'd find the hidden patterns yourself.
That is the big idea behind unsupervised learning. You give the machine a whole bunch of data with zero labels, and you just ask it to find the structure. It's amazing for things like clustering, where it might group your customers into different types based on their shopping habits, or find weird activity on a computer network that could be a cyber attack. It finds patterns we might never even think to look for.
All right, last one, and this might be the most fun one of all. Think about how you learn to play a new video game. You don't read a 300-page manual, right? No, you just jump in and start playing. You learn through pure trial and error. You try a move, see if you get points, or if you fail, and you adjust your strategy.
Well, that's reinforcement learning. You create an AI agent, and you drop it into an environment, like a game. It starts taking actions, and for every action, it gets either a reward or a penalty. Over millions and millions of tries, it slowly but surely figures out the absolute best strategy to get the highest possible score. This is how AI has mastered incredibly complex games like chess and Go.
Okay, wow. So let's just take a breath and recap the big ideas here. We learned that at its core, AI is all about simulating human intelligence. We know that the AI we actually have today is narrow AI. It's a specialist built for one job. We learned that the engine driving all of this is machine learning. And finally, we know that engine works in three main ways: by learning from labeled examples, by finding patterns on its own, or through trial and error.
And that leaves us with one last kind of mind-bending thought to chew on. We have actually done it. We've built machines that can learn from experience, a lot like we do. The path from the narrow AI we have today toward a potential general AI points to a future we can only imagine. So the question isn't really if machines can learn anymore, it's what does it mean for all of us when they finally become smarter than their teachers?